most of the companies think that once their data is encrypted, it's safe. That's the assumption.
But you leave the key on the hook right next to the word. The word security is irrelevant. Compliance is a snapshot. Security is a continuous state and it's been captured, stored in a database, and sometimes also detected.
We are talking about people inside the company being the threat. Hey everyone, welcome back to SecureDApp. As always, this is your host and host Kunal, and today I've been joined by Rahul Kumar, who is the product head of Quantum World. We will move further with him, but let me first introduce myself. I'm Kunal Chowdhury, marketing assistant manager at SecureDApp, and today we are going to discuss why cloud security might not actually protect your keys. So most of the companies think that once their data is encrypted, it's safe. That's the assumption, that's the belief, and that assumption is exactly what attackers are counting on. Now picture this 24 into 7 in the morning, no alarms, no red flags on dashboard, no phone calls to the CSOS. A set of API keys stored in a popular cloud platform have just been quietly exfiltered, not by breaking a firewall, not by brute forcing password. The attacker simply found the keys. And with those keys, they now have the same access as the application itself. Over the next 6 hours, 14 terabytes of encrypted customer data, financial records, identity documents, healthcare histories is copied to an external browser server or browser. The encryption was perfect, mathematically unbreakable, but it didn't matter because the keys were already gone. So today, to discuss with me on this topic, I have a very special friend of mine, Mr. Rahul Kumar. Rahul, if you would like to just introduce yourself, and after that, further.
Hi Kunal, thank you for the brief introduction on this topic. So I am the marketing lead of Quantum World. So very much excited for this topic. That's it.
Absolutely, Rahul. So, Rahul, I want to start with the most basic question. I think there is a massive gap between what people think encryption does and what it actually does, or rather, how it actually performs. So, what exactly is encryption key management, and why should anyone outside of a security team care about it?
Right. So let's start simple. Encryption at its core is a lock. You take your data, your files, your transactions, your customer records, and you scramble them using a mathematical algorithm. Once scrambled, the data is unreadable to anyone unless you have the key. The key is what unscrambles it. Now, here's the thing most people miss the strength of that lock. The AES 256, the RSA 4096, all of that is essentially perfect. Modern encryption done correctly cannot be broken by any computer that currently exists, not even close to it.
So, if encryption is that strong, Rahul, why are we even having this conversation?
Because the lock isn't the problem, the key is the problem. Imagine you have the most sophisticated vault in the world, reinforced steel walls, 6-inch titanium door, biometric locks, the works. But you leave the key on the hook right next to the vault. The vault security is irrelevant. The attacker doesn't need to break the door. They just grab the key.
Yeah, that sounds terrifying when you frame in that way.
And that's exactly what's happening at the enterprise scale. Companies spend millions, sometimes hundreds of millions, building encryption infrastructure, and then they store the key in software, in environment variables, in config files, in code repositories, basically on a hook next to the vault.
Okay, so encryption key management is managing these keys live, if I'm not wrong.
More than that, it's the full life cycle, how keys are generated, where they are stored, who or what has access to them, how often they are rotated, how they are revoked, when compromised, how they are audited, the operational layer on the top of encryption, and most organizations treat it as an afterthought.
Got it. So, Rahul, let's talk about cloud because I think this is where things get really interesting and maybe a little scary. Cloud providers, like we know, are AWS, Azure, Google Cloud. They spend billions on security. When we hear about that, their data centers are physically hardened. They have entire security teams, compliance certifications, the whole thing. So, why would an enterprise still be worried about key security if they are running on these particular platforms?
Well, this is the most important question in enterprise security right now. And the answer lives in something called a shared responsibility model. And I want to be clear, this is not a hidden gotcha in a fine print. AWS, Azure, Google, they publish this. They are explicit about it.
But most don't actually read that fine print.
Yeah, most enterprises don't understand what it means in practice. So here's how it works. The cloud provider is responsible for the security of the cloud, the physical infrastructure, the hypervisor, the network fabric, the data center. You, the enterprise, are responsible for the security in the cloud. Your configurations, your access controls, your data, and critically, your encryption keys.
So it would not be wrong if I say that AWS is the building, but you are responsible for what's inside your apartment.
Yes, exactly right. And the problem is enterprises have started thinking of cloud as a complete security solution. Like we moved to AWS, we turned on encryption. We are good, but enabling encryption in the cloud doesn't automatically mean your keys are safe. It often just means
But
the cloud provider is merging your keys for you.
actually, is that bad?
It depends on your threat model. If you are a startup and your concern is someone physically stealing hard drives, cloud managed keys are fine. But if you are a bank, a hospital, or a defense contractor, if you are dealing with the data where the cloud providers themselves could theoretically become a threat vector, or where regulations requires you to control your own cryptographic material, then handing your keys to your cloud provider is a significant risk.
Yeah, I can understand that. But Rahul, say more about that. The cloud provider as a threat vector. That sounds like something people don't want to think about.
Yes, and that's exactly why it's so dangerous. Look, I am not saying AWS or Google are malicious. They are not. But think about the attack surface. These companies are enormous. They have hundreds of thousands of employees. They have subcontractors. They have government relationships. If there is ever a security incident at a major cloud provider, an insider threat, a state-sponsored attack, a zero-day in their key management service, and you have handed them your keys, you have lost control of your data completely.
Absolutely. So, boardroom questions rather is, let me put on my CEO hat here. You are telling me that even if we do everything right, great cloud provider, encryption enabled, compliance checked, we might still be exposed.
Well, yes, and not because of bad luck, because of structural assumptions. The assumption is that cloud security is comprehensive. It's not. It's foundational. You still need to build on a top of it.
Cyber myth versus reality, Rahul. Let me throw this one at you. Myth, we are compliant, therefore we are secure. Often we hear this line. So, what do you think about it?
Yes, it is compliance is a snapshot. Security is a continuous state. PCI DSS, HIP AA, SOC 2. These are the incredibly important frameworks. They set baselines, but a compliance audit happens at a moment in time. It checks whether you had the right policies in place on the day of the audit. Attackers don't work on the audit schedules. Your environment changes every day. New services get spun up, keys get created, and misconfigurations happen. And compliance says you had the right locks installed last Tuesday. Security says, are those locks working right now?
Absolutely. And how many breaches have happened to a fully compliant companies? Because you have been leading this since last 5 months, so you might be knowing this.
Well, nearly every major breach in the last decade happened at the compliant organization, Target Capital One, Uber, Yahoo, all compliant at the time of the breach.
A- Absolutely. And that should make every seesaw in the world very deeply uncomfortable.
It should, and the honest ones will tell you they knew the gap exists. The problem is the gap is hard to sell to the board because the board sees the compliance check mark and thinks we are done.
Absolutely. Rahul, let's get into the most underreported attack vendors I have heard about, the GitHub leak problem. Because I know this is real. It happens constantly, and most people don't fully understand how catastrophic it can be.
Oh, this is one of my favorite things to talk about because it sounds so mundane. A developer pushes code to GitHub. They accidentally included a config file with a database connection string or an AWS access key or an API credential. Commit is public for 45 seconds before they realize a mistake and delete it.
45 seconds.
What a scanning GitHub in real time. Constantly. There are entirely automated systems, some criminal, some actually for legitimate security research, that are watching every public comment that moment it hits GitHub and extracting anything that looks like a credentials, AWS access key format, and even Google service account, JSON, strips, secret keys, private certificate files. They know the pattern.
So in 45 seconds, the key are already gone.
It's been captured, stored in a database, and sometimes already tested. Attackers will immediately validate, does this key work? What does it have to access it? And then they either use it, sell it on a dark web credentials, marketplace, or both.
Uh, if you don't mind me asking, Rahul, how common is this actually?
There are studies suggesting millions of valid credentials are leaked on GitHub every year. Millions. And this isn't just a startup developers being careless. This is the entire enterprise pool. Fortune 500 companies, government contractors, people who should know better because the development workflow of fast and human being make mistakes.
Absolutely. And if this happened tomorrow, let me play this out, Rahul. A developer at a major bank accidentally commits an AWS IAM access key to private repository. But let's say the repository had a brief period of public exposure due to a permission misconfiguration. What happens after that?
Okay, so even with a brief window of public exposure, let's say 2 minutes, if an automated scanner catches it, you are looking at a potential chain reaction. The access key probably has permission spoke to a specific set of services, but in large AWS environments, over provinced permissions are extremely common. Developers not given both permissions during development and they never get tightened. So that key might have access to S3 buckets, RDS databases, encryption, key management services. The attacker walk in using a legitimate credential. AWS logs show normal API calls, nothing looks suspicious. The attacker starts cataloging the environment. What data is here? What keys are exist? What other services are accessible? This reconcile phases can take days and then they decide their play. The data exfiltration, ransomware, or just sitting quietly and watching.
Absolutely. And I can feel that sitting quietly and watching, that's somehow more terrifying than an immediate attack.
Because the longer they are in, the more they will understand your environment. They map your architecture, they find your most sensitive data, and when they do move, and they will move, they hit exactly what matters the most.
Fair enough, Rahul. Rahul, let's talk about the insider threats right now because I think this is the one the organizations really don't want to admit is real. We are talking about people inside the company being the threat.
And this is statistically one of the leading causes of data breaches, not external hackers, people with legitimate access making legitimate choices or something being manipulated.
Okay. Can you walk me through an insider threat actually works in the context of uh, encryption keys?
Yeah, so imagine a cloud infrastructure engineer at a mid-sized financial services firm. They have legitimate access to the key management system because it's a part of their job. They are authorized, they are trusted. Now there are few scenarios. The malicious insider scenario, maybe they are being paid by the competitor, or they are disgruntled, or they are just optimistic. They copy a set of encryption keys to the personal devices, or they create a new access policy that gives their personal AWS account access, and none of this generates an immediate alert because the action is coming from an authorized identity.
Understood. So the system just sees a legitimate user doing something that looks like a legitimate action.
Exactly. And the most sophisticated version is the insider, where an employee's personal credentials get phished, their corporate laptops get malware, their VPN credentials get stolen. Now the attacker is acting as the employee with all of their access and all of their legitimacy.
Correct. So a boardroom question, Rahul. If I'm a board member listening to this, I'm thinking, okay, we do background checks. We have zero trust. We have access control. Why isn't that enough?
Well, because background checks are a point in time. Zero trust implemented properly helps significantly, but access controls only works if they are correctly scoped. And in most enterprises, they are not. The number of people who have broader access than they need is shocking. It's called permission creep. Someone gets elevated access for a project. The project ends. The access doesn't get revoked. 6 months later, that person or someone who compromised their account has access to the systems they haven't touched over a month.
And every one of those overprivileged accounts is an attack surface.
Every single one. In enterprise environments with thousands of employees and hundreds of services, the attack service from over provisioned access is enormous, and it's mostly invisible until something goes wrong.
Okay. Uh, Rahul, 30-second breakdown. I want you to explain API keys because we have mentioned them a few times, but I want to make sure everyone watching understand exactly what they are and why they are so dangerous.
Well, perfect. An API key is a credential that lets one software system talk to another. Think of it like a hotel key guard. The hotel has a front door, but instead of everyone having a unique lock, certain key guards open certain doors. When your mobile app talks to your bank's servers, there an API key involved. When a developer tool pushes code to GitHub, there is an API key. When your company's cloud service communicate with each other, there is also an API key everywhere. Now, unlike a password, API key are often designed for a machine-to-machine communication, which means they are embedded in code, configuration files, and environment variables. They are not typed by humans. They are built into applications, and that makes them so dangerous when exposed. Because the moment an attacker has a working API key, they can impersonate your application completely. They look legitimate, they will act legitimate. They have all the same access, and unless you have extremely granular monitoring, you won't know they are.
And these keys are just floating around in enterprise environments.
Exactly. In most enterprises, thousands of them with no central registry, no consistent rotation policy, some of them years old, some of them with excessive permission, some of them nobody even knows what they are for anymore because the person who created them left the company.
Yeah, that's the orphan credentials problem, right?
One of the most underestimated problems in enterprise security, keys and credentials that are still active, still have access, but are completely unmonitored because the humans who created them is gone.
Fair enough. Rahul, what about cloud misconfiguration? This one gets talked about a lot. But I don't think people understand the scale. Can you talk about what cloud misconfiguration actually looks like from key security perspective?
Cloud misconfiguration is consistently ranked as the number one cause of cloud security incidents. And the irony is, it's not a hacking problem, it's a human complexity problem. And cloud environments are incredibly powerful and incredibly complex. AWS alone has hundreds of services, each with its own access model, its own permission structure, its own configuration options. When you are building enterprises infrastructure, you are making thousands of configuration decisions, and a single wrong decision can create a big gap.
What does a wrong decision look like in a practice, Rahul?
A classic example is an S3 bucket Amazon file storage services set to public instead of private. This sounds like a beginner mistake, but it happens to sophisticated teams constantly, often because someone made a temporary configuration change to debug a problem and forgot to revert it, or because a tool they've used to provision the bucket had a default setting they didn't override. In 2019, Capital One was breached via a misconfigured WAF, a web application firewall. It allowed an attacker to perform a server-side request forgery attack and retrieve a IAM credential from the cloud metadata services.
And those IAM credentials are essential keys.
Exactly, IAM identity and access management credentials in AWS are cryptographic credentials. When someone steals those, they are not breaking encryption. They are using legitimate credentials to access their data. The encryption becomes irrelevant.
Fair enough. Cyber myth versus reality myth. Our cloud providers' default security settings are enough.
Well, reality is default settings are designed for ease of use, not security. Almost universally across cloud platforms, the default setting prioritize functionally over security. That means services are often left enabled that shouldn't be. Encryptions might not be turned on by default for all data stores. Logging might be capturing everything you need. Access policies might be the broader than you realize. Security is opt-in, and the sheer volume of the services in the modern cloud environment means that auditing every setting, every services, and every policies manually is a practically impossible.
So organization needs automation just to monitor their own environments.
They need it. They need automation. They need dedicated cloud security posture management tools. They need continuous scanning, and even then, things slip through. The cloud moves too fast. New services get introduced. Existing services get updated. The configuration shape is never static.
Got it. Rahul, let's talk about multi-cloud because I know this is where the chaos really starts. Most large enterprises aren't on just one cloud servers. They are on AWS, Azure, and maybe on Google Cloud as well. And they have some on-premises infrastructure and maybe some on the edge of computing.
Right. This is one of the most significant security challenges of the current era. When you operate in a multi-cloud environment, you are not just dealing with one set of security controls and one set of key management practices. You are dealing with two, three, four completely different systems, each with its own APIs, its own permissions models, its own encryption key hierarchy, its own audit logs.
And they don't talk to each other.
They don't talk to each other at all. AWS key management services uses a completely different model than Azure Key Vault, which is different from Google Cloud KMS. The credentials, the key types, the rotation policies, the audit formats, none of it is standardized. So now you have hundreds of thousands of encryption keys distributed across multiple platforms, managed by different teams under different policies no with unified visibility.
Okay, if this happened tomorrow, multi-cloud key chaos scenario, what's the worst realistic version of this playing out?
Okay, so imagine a global retail company. They run most of their customer data on an AWS. Their HR and financial systems are on Azure. Their analytics and machine learning workloads are on Google Cloud. So they have a key management system on each platform. Different teams manage each environment. The security teams has some visibility into each, but it's fragmented. Different dashboards, different alert formats, and different log structures. Now, attacker compromises the contractor's credentials. The contractor works on a data integration project that touches all three clouds. They have credentials in all three environments. The attackers starts moving laterally, and AWS first. They find and exfiltered a set of databases encryption keys. They move to Azure. They find the HR data also encrypted and quietly copy the keys. Then they go to Google Cloud. They access the analytics environment and begin exfiltering months of customer behavioral data. The security team in AWS spots an anomaly. They spend an alert, but the Azure team doesn't see it because it's a separate system. So the Google Cloud team doesn't see it because no one has built a cross-cloud correlation logic. The investigation takes weeks. By the time the full scope is understood, data from all the three environments are compromised.
And the encryption was working the whole time.
The encryption was working the whole time, but every data was encrypted, every storage bucket was encrypted, and it didn't matter
Yeah, because the keys were attack surfaces.
because no one had a clear picture of where all the keys were, who had access to them, and how they were connected.
Absolutely. So, Rahul, moving further, let's slow down and talk about why banks are different. Because every time I talk to people in financial services security, there is a level of paranoia that feels almost extreme compared to other industries. Why do bank treat key security so differently?
Because banks have been living with this reality for decades before cloud computing was even a concept. Banks were dealing with cryptographic key management because of ATM networks, because of payment processing, because of interbank transfers, HSMs, hardware security models were being used in a financial infrastructure in the 1980s and 90s. Banks didn't wait for the cloud security to catch up. They built their own cryptographic infrastructure because they understood the structure.
What are the stakes in banking specifically?
If a bank loses control of its cryptographic keys, the keys used to sign transactions, authenticate identities, protect customer account data, the consequences are immediate and existential. You are talking about fraudulent transactions that look completely legitimate. You are talking about identity impersonation of scale. You're talking about the potential collapse of the trust in the entire institution because banking is built entirely on cryptographic trust. Every transactions you make, every time you authenticate to your bank, there are keys behind the authentication. And if those keys are compromised, the attackers doesn't need to hack anything. They can sign fraudulent transactions, they can authenticate legitimate users, they can, in theory, you issue a themselves money to them also.
That's the nightmare scenario.
That's why HSM exists because banks needed a way to say this cryptographic operations will never only ever happen inside the physical hardware devices. The key never leaves the HSM. The key cannot be exported. All cryptographic operations, signing, verification, decryption, happen inside the hardware. Even if an attacker compromises your software, your servers, your cloud environment, the actual key material never existed anywhere they can reach.
A 30-second breakdown. HSMs, because I know we have mentioned them a few times, and I want to make sure people really understand what they are.
So an HSM is a specialized piece of hardware designed for one purpose to protect cryptographic keys and perform cryptographic operations securely. Think of it as a vault within a vault. The outmost vault is your data center and your cloud environment is your firewall. The HSM is a tamper-proof box inside the environment. It's physically hardened. If someone tries to physically open it or tamper with it, it will destroy the key material inside it. It's logically hardened. Even software running on the same machine cannot extract the keys from an HSM. It runs at cryptographic speeds. They are optimized for high throughput operations, and critically, the key material never leaves it. You send the data to the HSM to be encrypted or decrypted. The HSM processes it and returns the results. The key stays inside.
So, in simple terms, it would not be wrong if I say it's not just a storage, it's a processing environment.
Exactly, and that distinction matters enormously. Software-based key management, where your keys is stored in a database or a file or an environment variable, ultimately means the key has to be loaded into a memory to be used, and the memory can be read. HSMs eliminate that vulnerability by keeping the key inside the hardware at all the time.
Just curiosity, Rahul. Why isn't every company using HSMs then?
Well, historically, the credential HSMs are expensive and hardware appliances. They are require a physical installation, specialized expertise to operate dedicated network infrastructure for a small company. The cost was prohibitive. For a large company, scaling them across global infrastructure was complex. But that's changing with cloud HSM and HSM as a service model. The question now isn't whether you can afford it, it's whether you understand that you need.
Absolutely. Absolutely, Rahul. So, I think you have explained, yeah, and touched each and every most of the sectors that needs quantum vault as a service, because keys are the things that needs to be managed very, very carefully, because keys are the lead ways to datas that are very, very crucial, datas that are very, very important, and datas that needs to be kept safe. So with that, Rahul, I think we should be ending here. And thank you for joining, Rahul. Thank you so much for explaining the concept of HSM in such a easy way for the public to understand, for the viewers to understand. Thank you so much. Uh, with that, guys, if you like this video, please hit the like button, share this video with your friends, families, and colleagues. Subscribe to our YouTube channel, SecureDApp. We will definitely see you next time. But till then, stay safe, stay secure, and as always, I say, stay ahead. Thank you, Rahul. Thank you so much.